Okay, students, so next is question number 9. Quite similar with question number 8, okay? But you have to see the question very carefully. So see here, what they have given, you need to find out all the point of discontinuity in this question, okay? What you have to find, discontinuity means where, at what point the graph will break, you have to find out, okay? Now, if you see this function fx equal to x by modulus x, whenever modulus x is there we used to redefine it, right? So what we will write, let me write down this one. Okay, now see what they have given, fx equal to x by modulus x when if x is less than 0, means when you'll draw the graph, how you'll draw, you will take whenever you're taking x less than 0, those value if you take y, what will be y, you have to take this one. Okay, whenever you take x less than 0, y will be x by modulus of x. Now see, modulus x. Now x less than 0 means what? Negative numbers. All will be negative number, right? X is negative itself, right? Now see what kind of output it will give. X by modulus x. Now x itself is negative, right? So this numerator will not change. X will remain same. Now denominator, see carefully, if this is negative number, itself is negative number, now output will be what? Positive number. So exactly x will not come out here. So what will come out? See, this is negative, x itself is negative, right? But we know that output will be positive because of modulus function. Now to make this one positive, what you will do? X, this is negative, right? To make it positive, I will put one more minus here. Okay, now when you will solve this, suppose x is minus 1. So what you will get? Minus 1 by minus 1, which is equal to how much? Minus 1 by 1. Can you see the denominator is positive? So how you can make positive? By adding extra minus. So this is how we define modulus. Okay, so how I can write this one? Now in this case, now in previous case what we have done, we have taken less than 0 and then we have written this one, and greater than 0 means if it is positive, same value will come out, x by x, that is equal to 1. But in this case we will not take, because they have already defined it for only x less than 0. Greater than 0 we don't have to find or take this function. Is it clear? So in this case only this will be the output. Okay, so what I will write, x by minus x. Let me cancel this one and directly write down minus 1. Okay, so output here will be minus 1 if x is less than 0. Okay, and this will be minus 1. This is much more simple than question number 8, greater than equal to 0. This we don't have to redefine, it's proper one, right? So when your x is less than 0, what will be your y? Minus 1. So here somewhere, right? X minus 2, then y will be minus 1. X minus 3, then y minus 1. So the graph, what kind of graph you will get? Continuous, obviously, on your left. But 0 I didn't took till now. Okay? Just less than 0, whatever number is that. From there, if I plot all the point, you will see that this function will be continuous, this portion. It will never break at any point, because y equal to minus 1. Remember this function, what kind of graph it will represent? Straight line parallel to x-axis. Since x you have to take less than 0, that's why till here the graph will be constant like this. Okay, so at this in this graph there will be no break here, right? The graph will not break at any point on your left, right? Now the chances is at 0 it might break. So let's see, if you take x greater than 0 or equal to 0, if equal to 0 also give you this point, then it will join here. Okay, and greater than 0, if it gives points from here, then it will be continuous function, means there will be no discontinuity, but we will check that one. Okay, so till x less than 0 we have drawn the graph, it will be continuous on your left. I hope this you have understood. Graph of this one will be continuous. Okay, next, if x greater than equal to 0, what will be a y? Same, minus 1. If greater than 0, minus 1. Whatever greater than 0 you take, just next to 0 whatever number is there, for that you find out y, it will be minus 1, because constant, right? Minus 1 minus 1 minus it, you will keep on getting like this. So here also on your right side it is continuous, it will never break. Greater than and equal to 0, what it will be? At 0 minus 1, so this point is also there, so this graph will not break at all. So at any point this graph will not break. So what we will write? No points of discontinuity. Now this we have understood from graph, right? We have to write down in terms of limit. So see how we will write down. Now see here, we already know that x less than 0 on your left, it will be constant function, okay, I mean continuous function, right? Continuous function, it will not break, that is confirmed. Y equal to minus 1, we know the graph from class 11 only. This will be continuous graph. Now they have given condition x less than 0, so you, when you will draw graph for this, x you have to take less than 0. So when you will take x less than 0, y will be continuous, fx will be continuous for sure. Okay, so we are not going to check for less than zeros. It is confirmed, you know this from class 11. I have already explained in straight line. Remember what kind of picture all this equation represent. Those things I have already explained in detail there. Okay, so there I will not check. So where I will check then? At 0. Okay, at 0 we will check whether the graph will break or not, because we know that less than 0, this is the function, so obviously it will not break. Greater than 0, obviously it will not break. So at 0 whether it will break or not, we have seen that also it will not break from the graph. But how to write down? So at x equal to 0, left hand limit, find out. Limit x tends to 0 minus fx, how much it will be? Limit x tends to 0 minus, 0 minus means less than 0, close to it, right? So less than 0, which function? Minus 1, so answer will be minus 1 only. Fx, if it is constant function, where you will put x0, right? This is the output here. Next, right hand limit you find out. Right hand limit also you will get limit x tends to 0 plus fx, what will be greater than 0 also, minus 1, right? So what I can write here? Equal to minus 1. And this function actually you can redefine again. See here, fx equal to minus 1 if x less than 0, means your y is minus 1 if less than 0. When x is greater than equal to 0, then also minus 1. So can we write down like this? Fx equal to minus 1 for all real number. All real number. Like this also I can write, because for all real number you can see x less than 0 also, y is minus 1. X greater than equal to 0 also, y is minus 1. Means what? For all real number, y is how much? Minus 1 only, right? So I can write like this also, fx equal to minus 1 for all real number. So this you already know what is the graph, obviously continuous graph. Okay, so you can redefine also this one. Instead of writing like this, okay, I will show you in the next step here. Okay, so this is one way, equal to minus 1. Then you find out f of 0 is equal to how much? You will get, if you put x equal to 0, what is your y function? Minus 1 only. F0 will be minus 1. So you can see left hand limit, right hand limit, and your F0 is same. So what you will write? Therefore, okay, therefore limit x tends to 0, fx is equal to f0. Therefore f is continuous at 0. So you have to also write down, therefore there is no point of discontinuity. You can see the graph will not break at all. Then how you will get point of discontinuity, right? Point of discontinuity means what? Wherever the graph break, those points you have to write. Okay, that is called point of discontinuity. So here the graph will not break at all, right? So in every question you might have observed that I have explained the question with the help of graph as well as with the help of limit, because this is totally new concept for you, right? Limit you already got it, but I know most of the students still didn't understand limit. If you have not understood, then trust me student, you will not understand these things which I am writing right now here. So limit, based on limit, I have also made video in class 12 also. Okay, so you just watch those videos, try to understand carefully limit, then only you will understand all this. Okay, so if you have doubts in limit, you can ask me. So hence there is no point of discontinuity. So in this graph This function is totally continuous. Okay. Next question number 10. Okay, next is question number 10. So here also we have to check this function means graph of this break or not. At what point it will break, we have to find out that point of discontinuity. Okay. Now we know that fx equal to, if it is x plus 1 and nothing information is given here, suppose, then what you will say about the graph of this one? Obviously it is a straight line and it will never break, right? We have already done this one in class 11 in straight line. This is linear equation. So obviously this graph will not break. Now this graph is given for which condition? X greater than equal to 1. So this is your 1, suppose x. So when you will take equal to 1 and greater than 1, if you take, what will be a y value? X plus 1. That's what the meaning here, right? Now if you draw the graph of this one, how you will draw? Greater than 1. So you will take just after 1, whatever is there, 1.1, 1.2, whatever is there, x. You took that one. Then what will be a y? X plus 1. That is 1.1 plus 1. That is 1.01. Like that you will get, right? Somewhere here the point will be. Next point if you take, you will get one point here. 1.02 if you take, what you will get? Here also you will get 1.02 plus 1, that is 2.02. This also will be 2.01. Okay, 2.02. Like that you will keep on getting point. It will keep on increasing like this, right? So we know that if your x is greater than 1, we know that the graph will be continuous. It will not break because we have already done this one. Okay. So we are not going to check for this points, because why we are not going to check? Because they didn't ask you to check continuous functional. They are just asking you where the graph will break. So it's confirmed that the graph will not break here. When you take x greater than 1, we know that it will represent a straight line. Okay, infinitely it will go like this. Okay, so it will not break, that is confirmed. So I will not check at any point here whether the graph will break or not. We know that it will not break. Okay. Now at 1 it will break or not, that we don't know, because till now we don't know what will be the graph on this side. So at 1 I have to check. I hope you can understand. 1 I will check. Now see here again. For x greater than 1, greater than, let me check once again the question. This is not greater than 1. This should be less than 1. Obvious, right? So when your x is less than 1, equal to 1 they didn't say now. Equal to 1, they in this function only we got x plus 1. Equal to 1, if you take, what you will get? 2. Exactly 2 point you will get. Okay, add x equal to. Now x less than 1, just next to it when you will take, it will represent x square plus 1. X square plus 1, what graph it was? Do you remember still now? X square plus 1. It is a parabola, right? So it will represent a parabola. Just less than 1 if you take, it will represent parabola. Now from which point it will take? Suppose you take just less than 1. 1 you took. So 2. From 2 it will start. So graph, when you make it, we already came to know that if I take 1, then it will start from here only. If I take 1, what you will get? 2, right? You will get 2 here. So when you get 2 means what? Just before this, before 1, whatever value you have, x, if you take that, y you will get point here, 2. Okay. So from there your parabola will start. Now we know that this will also be a continuous graph. This will not break for sure. Parabola, remember what kind of graph it used to represent? Like this. And it never end up. It will keep on going like this. So obviously in this case it will never break, right? So here also just less than 1 if you start, it will represent a parabola. It might be like this, on whichever direction it might be. It might be lower or upward like this. Okay, and those also I have mentioned, right, where how you will check whether it will be upper or lower curve that we have studied in class 11. Anyway, we are trying to check whether the graph will break or not, right? Now the chances where the graph can break, only this point, right? Because we know that less than 1 if I take, it will form a parabola. Here less than 1, when you go further here like this point, at this points I'm sure that it will not break, because see, just less than 1 when you will start, it will go on your left only. Your parabola will go on your left like this, because x if you take here, y obviously upside or downside it will be, right? When you take x here, it will be upside or downside, means what? The point is suppose here, then the parabola will keep on moving on your left side like this, and I know that this graph will not break. So where the chances is there that it will break? Only this point. So we will check at x equal to 1. So that's why we will see whenever double definitions used to be there, we used to check limit for only these points, because we already know this graph will not break at any point. Okay, wherever it is defined at those point, on those point it will not break, that's confirmed, because we have already studied in class 11 this one. Okay, this represent one picture, this represent one picture. What kind of picture? It will represent a straight line, this will represent a parabola. Now this straight line you have to draw from x greater than equal to 1 from here. So when you will draw, it will go up like this, and we know that this side it will never break. Same with parabola, you have to draw from x less than 1. So less than 1 when you will take, I know that when you will draw from this side, it will never break this also. Okay, because you will see x, whatever you will take here on your left, it will be defined value, means y value will be there. Y value will be there means what? It will keep on joining those points. Okay, so there will be no break. So the chances is only here. From the graph we already got that here also it will not break. Okay, why? Because you can see x equal to 1 if I take, when you will take 1 here, this will be the point, right? When you will take less than 1, just less than 1 of if you take, it will start from here, right? And equal to 1 if you take here also, then what you will get? 2. It will obviously join. So still, if you have doubts here, this will clear in limit. Okay, if I draw the graph, obviously you will get continuous function. I will show you in the graph also. Okay, anyway, the chances, we were trying to find out at what point the chances is there that the graph will break. So this is the only chances, right? So let's check here. Rest we are not going to check. We will simply write that it will be continuous at every point except this point. If it breaks, then we will write except at this point. Okay, so let's find out whether at this point, means at x equal to 1, the graph will break or not. Okay, at x equal to 1, so now some student, what they used to do is they used to simply memorize whatever number is there, they used to check there. Okay, don't memorize all these things, because this understanding if you don't have, then some tricky question, it will be problem for you to solve it. Okay, so see here, at x equal to 1, I will check whether the graph will break or not. So what I will do, left hand limit, right hand limit, we will find out, and we will find out at x f of 1. F of 1 we will find out, and we'll see whether all three are same or not. So left hand limit, limit x tends to 1 minus fx. 1 minus means just less than 1, right? Less than 1 means this function. Limit x tends to 1 minus x square plus 1. So this is defined function, determinant value, right? If I put 1 here, so directly put it, what you will get? 2. Let's find out here. Limit x tends to 1 plus fx. 1 plus means greater than 1. So greater than 1 means x plus 1 function. Limit x plus 1, x tends to 1 plus. So what I will do, it is determinant value 1, can I put it directly? So 2. So left hand limit, right hand limit, we got 2. So let's find out f of 1. F of 1, x equal to 1. If I take x equal to 1, what is the function? This one. So if I take x equal to 1 here, what you will get? 2. So you can see left hand limit, right hand limit, and all are same, equal. So what I will write, therefore limit x tends to 2 fx is equal to f of 2. So this is the definition of continuous function. So the function will be continuous at 2, and rest also we know it is continuous. We are not going to check there, because they have only asked you to find out the point of discontinuity. So what you will show, there will be no point of discontinuity. Since f is continuous at all point, at all real number, you can write real number, right? We have already got at all real number it will be continuous. At 2 we have doubt, we have checked there, and we have seen that at 2 also it is continuous, graph will not break. And rest we already know it will not break, right? Since f is continuous at all real number, therefore there is no point of discontinuity. Okay, So question number 11 and 12, you try yourself, student, and let me know if you can do it or not. Okay, in next video I will solve question number 13, then we will move to question number 7 back. Question number 7 is triple definition is there, right? Function is defined in three functions is been defined there. So that function, how to deal in terms of limit, that we will learn.